Hi everyone, I'm Adrian P. Ohoylan, and today I'm excited to share what I've learned about operating system with Sir Dublar. In this short video, we'll cover key concepts from the lesson I've studied, including the basics of OS, MS-DOS, and the different scheduling algorithms. Let's get started. Let's start with an operating system. OS is the core software that manages a computer hardware and software. It acts like a bridge between users and the hardware, enabling us to run programs, manage files, and more. These are the different types of OS, like batch systems, time-sharing system, and real-time system. For example, a time-sharing system lets multiple users share a computer resource simultaneously. One key role of an OS is resource management, deciding how the CPU, memory, and storage are allocated for tasks. Without it, multitasking, as we know, it wouldn't be possible. Next, let's talk about the MS-DOS, an early single-tasking operating system with the command line interface. It's simple but laid the groundwork for advanced OS we use today. CPU scheduling is a critical function of any OS. It ensures the processes are executed efficiently by deciding the order in which tasks access the CPU. This becomes especially important when multiple processes compete for resources. CPU algorithms helps an OS decide which tasks to prioritize. Let's explore a few. First is a first come, first serve, where tasks are executed in the order they arrive. Think of it like waiting in line at a grocery store, simple, but sometimes inefficient if a large task blocks a smaller one. Next is shortest jobs next. This algorithm prioritizes shorter tasks to minimize waiting time. For instance, imagine a processing quick emails task before starting a lengthy video rendering. Both algorithms have their pros and cons, and understanding them help us to see how computers balance efficiency and fairness. Now, let's talk about the round-robin scheduling, one of my favorite. In this algorithm, each task gets a fixed time slice, or quantum, and the CPU cycles through all tasks in round-robin fashion. This ensures fairness as every process gets a turn. It's commonly used in time-sharing system, like when a multiple user share a single server or when we run multiple apps on our PC. For example, imagine sharing a game time among friends. Each gets an equal turn before the cycle repeats. Lastly, we have the longest job first. This algorithm gives priority to the largest task first. It's great for batch processing system where completing biggest jobs early is beneficial. However, shorter tasks might have to wait a long time, leading to potential delays. This highlights the trade-offs OS designer must consider. Learning about these algorithms has been eye-opening. For example, I now understand how my computer multitasks, playing music, running a browser, and editing a document seamlessly. It's fascinating to see how scheduling algorithms make modern computing efficiency, balancing speed and fairness. Thank you for watching, guys. I hope you've enjoyed this quick overview and learned something new. See you on my next video.